Hello, everyone. Mr. Sutherland here, and today we are going to start our final section this year and our final section, this chapter that begins to introduce one of the main ideas of calculus, and that is the idea of the derivative. And so, what we're going to start with today is average rate of change, which is an idea you've been doing for many, many years. How do things change over time? And from there, we'll develop over the next block the idea of what is the derivative? What does it represent? So let's start with an average rate of change problem from a graph. So it says it takes you 60 minutes to drive from Glenview to Milwaukee, a distance of 60 miles, as represented by the graph below. Find the average rate of change from time 0 to time 60. So average rate of change is simply the slope. It is, we think of it as change in y over the change in the x value. Sometimes this is referred to as delta x over delta y. When we talk about these problems, average rate of change really represents the rate of change is the velocity. So if I want to know the average rate of change from 0 to 60, as it asks me here in question C, I'm going to go kind of out of order here. All I need to know is what's the value of the function at 0? Well, that's the point 0, 0. What's the point at 60? Well, that point is 60, 60. And really, average rate of change is just asking me to find the slope of this line that goes through those 2 points. So this line that passes through 2 points, that is called the secant line of a graph. So another interpretation of average rate of change is the slope of the secant line between 2 points. And so literally, if I want to find the average rate of change here, I just do 60 minus 0 over 60 minus 0, which is 1, really, 1, and our units is miles per minute. That's what we are going, those are the units. The change in y were in miles, the change in x was in minutes. So if I look at this graph from 0 to 10, so 0 to 10 looks like this. Now look at the slope. That's a steeper line. The average rate of change should be greater. So from 0 to 10, well, I know it's 0. The distance traveled was 0. I know at time 10, they had traveled 20 miles. So over that time, we have 20 minus 0 over 10 minus 0. We get 2 miles per minute. So in that time frame, the car was averaging 2 miles per minute. Now, what happens from 10 to 30? Well, if I look at 10 here and I look at 30 and I draw the secant line, notice that secant line is horizontal. That means the car was not moving. The velocity was 0. And I can look algebraically at 10, they were 20 miles away. At 30 minutes, they were still 20 miles away. So when I do my average rate of change, which again is just slope, I get 0 over 20, which is 0 miles per minute. And notice these values represent the slope. The slope is 2, up 2 over 1. Here, the slope is 1, up 1 over 1, up 1 over 1. And then here, a horizontal line has a slope of 0. So average rate of change looks at this thing called the secant line geometrically. And how is it changing? All right. Number 2, use this table of values to find the average rate of change from 1 to 4. So all I have to do is, and if I think function-wise, when I do average rate of change, then I have f of 4 minus f of 1 over 4 minus 1. Well, according to my table, f of 4 is negative 11, f of 1 is 1 over 3, so I have negative 12 over 3, which is negative 4. So my average rate of change from 1 to 4 is -4. So first we saw it from a graph. Now we've looked at it at a table. Now the third way we're going to do it is look at a function. So number 3, for the function f of x equals x squared minus 3, find the average rate of change over the interval -1 to 4. So again, average rate of change just means I'm going from -4 to 1 is that I'm going to do f of 1 minus f of -4 over 1 minus -4. Well, I may do these over to the side here. F of 1 would be 1 squared minus 3, which is -2. F of -4 will be 16 minus 3, which is 13. So I have -2 minus 13 over 5. So -15 over 5 is -3. So if we think of this as being a position function, this would be the average velocity. And so the negative would indicate moving back towards home or to the left or right, depending on how it's classified. Number 4, for the function f of x equals 1 over x, find the slope of the secant line. Now, this slope of secant line, it's not asking anything different. This is asking for the average rate of change. That's what the slope of secant line represents. So again, we're going to do f of 3 minus f of 1 over 3 minus 1. So over here, I'll do this. So f of 3 is 1/3. F of 1 is 1. So we end up with 1/3 minus 1 over 2. So -2/3 divided by 2, which ends up being -1/3. So the slope of the secant line is the average rate of change. Now, 5, for this function, find the average rate of change from 2 to 2 plus h. So in this case, h is just this amount that we're moving away from 2. So let me show you a Desmos thing here so you guys can see what this is talking about. So right now I have a function. I have let me set the a value here on this to 1. And I have h to be 1.9. So that means my next point is 1.9 units away. So if I put h at 2, that means my next point is 2 units away. So I'm just looking at x equals 3. And what we're going to do and why we introduce this notation is I want to look at what happens as this h value gets closer and closer to 0. And what you'll notice is this secant line ends up becoming what's called a tangent line. And that's what we're going to talk about next time. But right now, we want to be able to find a formula in terms of h so that if I wanted to find the average rate of change between 2 and 3, 2 and 4, 2 and 5, 2 and 6, I wouldn't have to keep calculating the whole time. I would just have to plug in what h would be. So let me show you how this works with this problem. So my average rate of change means I am going to do, this is my if I want to think of my first point is 2, and I have f of 2. My second point is going to be 2 plus h, and I'm going to have f of 2 plus h. So f of 2, that's easy to find, and I'll do that over here. F of 2, well, that is 2 squared, which is 4, minus 2, which is 2. F of 2 plus h. So remember, what function notation tells us to do? It says anywhere we see an x, we're going to replace it with 2 plus h. So I have 2 plus h squared minus x, which is 2 plus h. Now I need to expand this out. So 2 plus h squared means 2 plus h times 2 plus h, which is 4 plus 4h plus h squared minus 2 minus h. And this simplifies, let's see, we get h squared. 4h minus h is 3h. 4 minus 2 is 2. So here is what f of 2 plus h is. So now I'm going to do our average rate of change formula. So I have f of 2 plus h minus f of 2 all over h. So, or excuse me, all over 2 plus h minus 2, right? Just doing my slope formula where this is x1, y1, x2, y2. So that gives me, we know f of 2 plus h, we already have is h squared plus 3h plus 2 minus f of 2, we got to be 2. And the bottom all simplifies to be h. So now I have h squared plus 3h all over h. Everything has an h, so I get h plus 3. So here's what that tells me. If I wanted to know the average rate of change from 2 to 3, well, if I'm looking 2 to 3, that means h is 1. 1 plus 3, the slope is 4. If I want to know the average rate of change from 2 to 6, well, from 2 to 6, h would be 4. That slope is going to be 7. This becomes something that we're going to use a lot. This idea here is called a difference quotient. And we're simplifying it in that problem there. All right, now last one. For this function, x squared minus 2x, find the average rate of change from x to x plus h. So now we don't even have a starting point. Our starting point is x, and we're going to x plus h. So my first point is x, and then f of x. My second point is x, and f of x plus h. So f of x, we know what it is. It's x squared minus 2x. That's pretty easy. F of x plus h takes a little work. So f of x plus h means I'm going to put x plus h squared, again I'm putting it in for x here, minus 2 times x plus h. Now I'm going to write this out the long way here. This really means x plus h times x plus h minus 2x minus 2h. Now I have x times x is x squared, xh plus xh would be 2xh plus h squared minus 2x minus 2h. None of that can be simplified. So now, let's see what I have here when I do the average rate of change. So, average rate of change, I've got f of x plus h minus f of x over x plus h minus x. So, this thing right here, that is this. So I'm going to write that right there. So that is x squared plus 2xh plus h squared minus 2x minus 2h minus f of x. Well, f of x is just this. So minus x squared minus 2x. And then that's all going to be over. Well, if I do x plus h minus x, that's just h. Now let's see what simplifies here. Notice x squared minus x squared. That goes away. Negative 2x minus negative 2x. That goes away. So what am I left with? I'm left with h squared plus 2xh minus 2h all over h. And now everything has an h, so this simplifies to h plus 2x minus 2. And so if I told you what x and h are, you now can find the slope of the secant line between any 2 points. This is also a difference quotient. It's a general difference quotient. Instead of having a starting point like we did here, we're doing it from x to x plus h. And these two ideas in 5 and 6 are what we're going to investigate next class. What happens as we look at this difference quotient and we go back to our example here, and what happens as we get this value, this h value, closer and closer to 0? What does that represent for the function? So try the delta math that goes with this, and then next time we'll spend some more time with this. Take care, guys. Bye.